Hello, this is Mr. Moeller for lesson 2-3, solving two-step and multi-step equations. So this will be basically a day of putting together what we did in 2-1 and 2-2, and it kind of has a reverse order of operations where we're going to add or subtract first, and then our last step should be to multiply or divide. The first problem I want to look at is something that could, real life example. So Alex belongs to a music club, and this club students can buy a discount card for $19.95. This card allows them to buy CDs for $3.95 each. After 1 year, Alex has spent $63.40. Find the number of CDs that Alex bought. So this is kind of, with those discount cards, or like with Sam's Club and Costco and things like that, where you're buying a discount card versus paying full price. Well, sometimes it makes sense to buy the discount card if you go there a lot, and sometimes it doesn't if you don't go there a lot. So in this case, they're telling us that we know he spent $19.95 on this discount card, and then $3.95 for each CD. And total for the year, he spent $63.40. We're trying to figure out how many CDs he bought. Okay, so we'd write it out as $3.95 times C, because we don't know how many CDs he bought, plus the $19.95, because we know he spent that just one time, that's why there's no variable, equals $63.40. So first, we're going to end up subtracting $19.95 from both sides. So kind of like I said, the opposite order of operation, we need to get the variable by itself. So we're going to subtract $19.95 from both sides. And that's going to give us $43.45. And then once we have $3.95 equals $43.45, we're going to divide those out, and you'll end up with 11 CDs. And then we can always go back and check our work. So if we went back to the original equation and said 11 times $3.95 plus $19.95 would give us that $63.40. Alright, and this is more like what the book problems are look like. So if I have 4a plus 10 equals 18, I'm going to minus 10 from each side. Remember, if I do it to the left side of the equal sign, I have to do it to the right side of the equal sign. So I'm going to end up with 4a equals 8. I'm going to divide both sides by 4 and end up with a equals 2. And just like with the first section, I can always go back and double check my work to see if it makes sense. Okay, so 4 times 2 is 8. 8 plus 10 does equal 18, so I know that I'm right. Alright, here I have a minus 4, so I'm going to add 4 to each side. Draw my line for the equal sign. Add 4 to each side. And I'm going to end up with 7x equals 7. Alright, it says 7 times x. Opposite of times is divide. So divide both sides by 7. 7 divided by 7 is 1. So again, I can go back and check that. Negative 4 plus 7 times 1 is 7. Negative 4 plus 7 does equal 3. It doesn't change anything if there happens to be some fractions in there. Same process. This says plus 2. I'm going to subtract 2. Subtract 2 from both sides. I have n divided by 7 equals 0. It says divided by 7, so I'm going to times by 7. 0 times 7 is 0. So n equals 0. Nothing changes with fraction. Still the same steps of subtract first, or add or subtract first, and then multiply or divide. Same thing with distributive property here. So let's rewrite this as 4x minus 8 plus 2x equals 40. Remember, when I am distributing to both. So 4 times x and 4 times negative 2. Alright, and then I can simplify this. I have a 4x and a 2x, which is going to give me 6x. I have a minus 8, so I can add 8 to both sides. So add 8 to this side. So I have 40 plus 8, which is going to give me 48. So I have 6x equals 48. Divide both sides by 6. and x is going to be 8. And then again, I can go back and double check that, which with these big long ones with the distributive property, is a really good idea. So if I put in an 8 here, and an 8 here to make that a 16. Okay, so 8 minus 2 is 6. 6 times 4 is 24. 24 plus 16 does give me 40. So always pretty much going to be the same rules of add or subtract first, and then multiply or divide. Doesn't matter if there's fractions or decimals or distributive property. It's the same steps no matter what.